Hi, Year 11s. Here is the walkthrough of the tech-free practice test we did. I'll go through it pretty quick just so the file isn't too large, but we'll go through some of this in class as well. So let's have a look here. This first one was interesting. A lot of people made an error, which was just that people were trying to sort of bring the 9 over to the other side and then got 49x squared minus 9 equals 0. And then some people recognize that it was a difference of perfect squares, which is totally fine, but it's probably not the most efficient way to solve the problem. You could have done it that way. I'll just show people what that way is. If I subtract 9, then it equals 0. Well, it's a difference of perfect squares because it's 7x all squared difference, so we're subtracting 3 squared. That equals 0. And we know that the difference of perfect squares says that if you've got a squared, let me use a different color. If you've got a squared minus b squared, and you need to factorize that, well, it's just the a part minus the b part times the a part plus the b part. So that is the difference of perfect squares. So if we go back to the actual problem we had, what we would have is 7x plus 3 times 7x minus 3. All of that, remember, equals 0. And then if we solved each of those, so we say the first bracket is equal to 0 or the second bracket is equal to 0, we're going to get two solutions. The first one is going to be negative 3 over 7. And the other one's going to be positive 3 over 7. So there's our two solutions for x. Let me make sure I write x there. So that's one way you could have done that. The other way, and hopefully I'll be able to squeeze it in, to use this, I think is a bit more straightforward. Because there's only one x term, it's an x squared term, but there's only one x squared term, what we can do is we can just rearrange and solve it. So if we take this over here and say, all right, well, 49x squared equals 9, then x squared, we can divide both sides by 49, so we're going to get 9 on 49. And then we're going to get x. All right, now we need to take the square root of both sides. So remember, when we take the square root, it's plus or minus the square root, 9 on 49. Now, this is where dealing with surds is something that a lot of people seem to need to review, which is fine. You can go have a look maybe in a year 10 or year 9 textbook. But basically, if you've got a surds as a fraction, you can write it like this. You can give them each their own surd sign. And then if we keep coming down here, square root of 9 is 3, and the square root of 49 is 7. So either way works. I would probably suggest this way here, which is, for me, a bit quicker. All right, let's do the next one. The next one says we've got x squared minus 42 equals x. Most people were pretty good at this one, so good job. What we can say is, if we rearrange it, we're going to get x squared. If I take the x from this side, so take x from both sides, it's going to be minus x minus 42 equals 0. All right, then what you can do is, all right, you ask yourself what multiplies to give negative 42. So A is 1, C is negative 42, so A times C is negative 42, and adds to give a negative 1, because our B value is negative 1. And what we can see is that negative 7 plus 6 would work. Because negative 7 times 6 is negative 42, and negative 7 plus 6 is negative 1. So what you can do from there is, you know that when you factorize it, you're just going to be able to write it like this. Because it's monic, it's more straightforward. You just go x minus 7, x plus 6 equals 0. Using the null factor law, x equals 7, or x equals negative 6. And that's your solutions there. Next one, is an inequality, so this is reasonably fresh to people. So let's have a go at this one. Remember, what we need to do when we have an inequality is to solve it as if it was normal, and then find those x-intercepts and then draw a graph and then interpret that graph. So let's have a go. First thing we want to do is, all right, we want to factorize this, because when we can factorize it, then we can find the intercepts. So AC is 6 times 6, which is 36. So we're looking for numbers that multiply to give 36, but add to give 13. If you need to go back and practice factorizing monic and non-monic quadratics, this is the type of skill that you'll need to be able to do to solve quadratic inequalities. So what multiplies to give 36 and adds to give 13? 9 and 4, both positive, seems to work pretty good for me. And in this case here, I'm going to do the whole process so that people can see what it is that we're actually doing. So we're taking 6x squared, and with the 9 and the 4 that we just found, we're going to break that 13x up into those two terms. So let's do that. So it's going to be plus 9x plus 4x. Haven't changed anything. This part here is just 13x plus 6, and all of that has to be less than 0. Okay, what we can do here is, all right, now we just factorize by grouping. So we look halfway on the left and then to the right, and we can see the highest common factors. So this one here is going to be 2x is the highest common factor, and we're going to be left with 3x inside. No, it's not. 2x isn't the highest common factor. 3x is the highest common factor. And we're going to be left with 2x plus 3. All right, here, the highest common factor is 2. So we're going to take a positive 2 out the front. We're going to be left with x plus 3. All of that, remember, has to be less than 0. And rookie error, when I took 2 out as a factor of 4x, that's going to give me 2x plus 3 less than 0. And now the highest common factor is 2x plus 3. So that comes out the front because that's in both terms. And we're left with 3x plus 2. Okay, all of that has to be less than 0. Now, if we thought for a moment that this was an equal sign and thought about the x-intercepts, well, we can see that one of our x-intercepts would be at x equals negative 3 on 2, if we solve that. And this one would be at x equals negative 2/3. Now, someone asked an interesting question in class earlier. They said, how do I know which one's larger and which one's smaller in terms of where I'm graphing it from my rough sketch? Well, think about it like this. This is an improper fraction. So the number on top is larger, which means this number is larger than negative 1. This number here is a proper fraction, which means the number on top is smaller, which means the number is between 0 and 1, or in this case, between negative 1 and 0. So negative 3 on 2 must be further left than the other one. So this would be negative 2/3, and this one further left is negative 3 over 2. If you put it as a decimal, negative 3 over 2 is something like negative 1.5, and negative 2 over 3 is something like negative 0.7. So you can always do it that way as well. All right, then you just do a rough sketch, doesn't have to be perfect. All right, and we're interested, remember, in where this is negative. So it has to be less than 0. So let me highlight all that bit. That's all this bit down here. So the way we write that is the function is negative, or the graph is negative, let's say, when your x values are greater than negative 3 on 2, but less than negative 2 on 3. And that's how you would write it, using what we call set notation. If you're really stuck, you're able to write a sentence. Okay, you can just write a sentence in English, just a normal sentence, and just say x has to be greater than negative 3 on 2 or less than negative 2/3, and the whole thing will be negative. All right, this one here, people did the hard way and they got the right answer. People tended to expand it and then tried to solve it that way, which is fine, but we're always looking for the most efficient strategies. In this case, what we can do is we can let x minus 2 equal some letter that we make up. Let's call it a. Okay, just to make it easier to solve. Now, some people did this but they let x minus 2 equal x. Now, from an examiner's point of view, or whoever is marking your test, my point of view, that's a confusing, it's a confusing letter to pick, because, in fact, given that x should be the same, given that we're solving this problem, it's probably incorrect to use x as a substituting in the variable. So you do need to choose another letter and just write the word let. So let x minus 2 equal a. And then what you'll get is, all right, wherever you see an x minus 2, he substituted an a. So it's going to be 2a squared plus 5a minus 3 equals 0. All right, let's keep going. Now what we can do is we can factorize it. What multiplies to give negative 3 times 2? Negative 3 times 2 is negative 6, and adds to give 5. All right, what two numbers are looking good? I reckon it's going to be 6 and 1, but one of them has to be negative, and it has to be that one. Okay, so it's going to be, let's go through the process, 2a squared plus 6a minus a minus 3 equals 0. Now we factorize by grouping. 2a is the highest common factor of the first bit, and you're going to be left with a plus 3. And the other bit, well, what we can do is we can take out negative as a factor. We're going to be left with a plus 3 as well. Negative 1 as a factor, I should say. And then we can see that we're going to be left with this. We're going to have a plus 3 is now the highest common factor, because it's in both. There's an a plus 3 there, there's an a plus 3 there. So I'm going to take that out the front. And then we're going to be left with 2a minus, well, there's an imaginary 1 there. So, and that equals 0. Now, applying the null factor law, if we move down a bit, we're going to get a equals negative 3 and a equals positive 1/2. But we're not done, because remember, what we did was we let x minus 2 equal a. So we just need to substitute that back in. So don't forget this step. X minus 2, well, a was equal to negative 3, so now x minus 2 must be equal to negative 3. So in this case, x equals, just solving this part of it, is going to give us x equals negative 1, because we add 2 to both sides. And over here, x minus 2, which is just a, is equal to 1/2. Now what we need to do is add that to both sides. So if I add 2 to both sides, I'm going to get 2 plus 1/2. Well, that's 2.5. And I know that 2.5 is half of 5. So 5 on 2. And there's our two final solutions. X minus 1 and x equals 5 on 2. Now, the next bit says use the quadratic formula to find exact values of x, given that that's the case. Now, I really like this question because it tests a few things. One of the things is the following, which is that you need to remember the quadratic formula. Because in class we said that the quadratic formula is the general solution to the general form. So what I mean by that is we have this as our general form. If we let that equal 0, so we let that whole thing equal 0, what we're trying to do is we're trying to find y-intercepts. And I don't know why that's negative. So let me try that again. 0 equals ax squared plus bx plus c. So if we have our general form equal to 0, if we complete the square and then solve for x, we get the quadratic formula. So the point I'm trying to make is you need to know the quadratic formula. And a lot of people made errors just in recalling it. So let's make sure we're putting that in our notes, or we're trying to put that around the room or something so that we can remember it. Because if we can't remember it, we're going to be in trouble. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. Now, you'll notice that this is not in general form yet. It needs to be rearranged to be put into general form. So let's do that. We're going to get 2x squared. All right, if I add minus 6x to both sides, it's going to become plus 6x. And this is plus 2, so it's going to be plus 2 equals 0. All right, so we can see that this is A, this is B, and this is C. Now, the one thing I don't think anyone noticed was that there's a common factor here. And let's show one thing. If we take 2 out the front, we're going to be left with x squared plus 3x plus 1 equals 0. Now, hopefully you can see that if I divided all this by 2 and then divided that by 2, that would go away and that would still be 0. So basically, we can divide both sides by 2 and we're still going to be left with the same problem. So let's just work from there if my computer will let me erase that. So we can just solve this, which is a little bit easier. So always looking out for seeing if you can take out a common factor. So in this case, it's easier. A is 1, B is 3, and C is 1. So we're going to take negative B, so it's going to be negative 3 plus or minus the square root of B squared. All right, lots of brackets. 3 squared minus 4 times 1 times 1 all over 2A, which is 2 times 1. No, so that's going to be negative 3 plus or minus the square root of 9 minus 4 over 2, which equals negative 3 plus or minus the square root of 5 over 2. And that's not going to fit in. Negative 3 plus or minus the square root of 9 minus 4 is 5, all over 2. Now, it's important that you do take that factor out because this is the most simplified version of your answer. A lot of people use this as A, B, and C. They use these values as A, B, and C, which is fine. You get the same answer, but the answer you get isn't simplified. So you would have to do another step from here, and you would have to continue simplifying your surd, and it would mean you have to take out a factor of 2 and simplify things. So always make sure you're looking out to take out any factors where you can, so that when you have to apply the quadratic formula, you get the most simplified version out. Okay. For which values of k does the equation this have 2 solutions? So this question's a bit tricky, but it's actually reasonably short if we have a good understanding of what's going on here. So let's break it down. What we've got is we've got a quadratic and it's equal to 0. So we're trying to find, it's looking for x-intercepts, but we're saying we have 2 solutions. So when we see this word solutions, what I want you guys to think about is x-intercepts. So we want values of k where this graph has 2 solutions. So let's have a think what it means to have 2 solutions. So as a quadratic, if we have some quadratic, has whatever rule it's got, maybe it's like this. This would say it would be no solutions. There's no x-intercepts, no solutions. Something like this, where it just touches, is 1 solution. And you guessed it, something that crosses it, like this, has 2 solutions. Alternatively, it could be a minimum, sorry, it could be a maximum as well. So it could be like that, it would have 2 solutions as well. So it's, what we can say from here is we needed to have 2 solutions. And the thing we know is that when the discriminant, which we spoke about in class, and this thing is greater than 0, so it's positive. Let me write that down. So when b squared minus 4ac is greater than 0, there are 2 solutions. So there's 2 x-intercepts. Two x-intercepts. So that's what we want. So we need to make the discriminant greater than 0. So let's do that. Let's find out what the discriminant is. Well, 2 is the a value, 2k is the b value, and k is the c value. So let's write that. So a, b, c. So b squared minus 4ac. Well, b is 2k, so let's put that in. So it's going to be 2k squared minus 4 times a, well, that's 2, and c, which is k. So we're going to get, and that all has to be greater than 0. So 2k squared is 4k squared minus 4 times 2 times k is minus 8k. And all of that has to be greater than 0. Okay, so now what we have is a problem very, very similar to the one we did before. It's this problem here. We have to solve a quadratic inequality. If we look at this, it's quadratic. It's not x anymore, but it's still k. So what we're trying to do is we're trying to find values of k where this is positive. So what we first want to do is to factorize it. And what we can do to factorize it is by look at it, and we can put it in intercept form. We can say 4k is a common factor, and we're going to be left with k minus 2, and that's going to be it. And that all has to be greater than 0. All right, so just as we did before, we just need to sketch the graph. So let's do that. And the reason we're sketching the graph is to see where this whole thing is less than 0. So let's remember here, if this, again, similar to the previous problem, if this was an equal sign, we could apply the null factor law. And if we can apply the null factor law, that means we can find the x-intercepts, or in this case, the k-intercepts. Don't worry too much about that. But what we can say is that if either 4k equals 0 or k minus 2 equals 0. So if 4k equals 0, then k equals 0. So that must mean there's a, let's say, k-intercept at the origin, because k is 0 there. And the other one is k minus 2 equals 0. So in that case, k equals 2. So there must be another k-intercept here. So doing a rough sketch, I can see that it's a positive k squared value. So I know it's a smiley face. If it was negative, it'd be a sad face, but this one's a happy one. So we go like this. And we're looking for where this is positive. So let's use a different color. Let's use orange. Positive from here to here. And positive from here to here as well. All right, so what we can say is the way we want to write this is, we know that this is the point 0 and this is the point 2. So we know that when k is less than 0 and when k is greater than 2, that this whole thing is positive. So just a note on some of the notation we're using here. This is the union sign, which you would have seen before, hopefully. So we're just saying k can be less than 0 or k can be greater than 2. So what we're saying is, if we look at the big picture of what we've done here, if I just rub that out for a second, what we can say is we can substitute in values for k here. And if we substitute in those values for k, if k is less than 0 or greater than 2, the graph that we're going to get for this whole thing is going to have 2 solutions. So it's going to go something like this. It's going to have 2 solutions. If k is less than 0 or k is greater than 2. If it's let's say in between those 2 values, it's going to have no solutions. So it's going to be something like this. So that's sort of what we've done. We've said, all right, what are the values of k that if I put a k here, and the same k here, obviously, if we put a value of k in, what values can I put in that are going to make that whole thing have 2 solutions? And what we're saying is, all right, if k is less than 0 and if k is greater than 2, there's going to be 2 solutions to this quadratic. Okay, and remember, just when we say solutions, we're talking about intercepts. So when k is less than 0 and when k is greater than 2, there's going to be 2 x-intercepts for this equation. All right. Now, these types of questions trip people up a little bit, so let's go through it as carefully as we can. A parabola has x-axis intercepts of -1 and 2 and passes through the point 3, 6. Find the equation of the parabola. All right. Let's just recap really quickly. There's 3 different forms of a parabola. And the final one is this one, ax minus b. Right. This one's the general form. This one is turning point form. And this one is intercept form. Now, in this case, they've given us 2-axis intercepts. So you might guess that we're going to use this form. And when I say we're going to use this form, we're going to use this as a general format, and then we're going to substitute in points and then find what A, B, and C are. And then that'll tell us our equation. So let's do that. We know that in this form, let's do an example. So let's say y equals x minus 2 and x minus 3, just as an example to wrap our head around it. We know that if we let y equal 0 here, that we could apply the null factor law. And remember, when we've let y equal 0, we're finding x intercepts. So there'd be one at x equals 2 and there'd be one at x equals 3, like something like this. Okay? So what we can say is, looking at this over here, we can say, all right, there's an x-intercept at B and there's an x-intercept at C. So we're already halfway there. So what we can say is, all right, y equals A. We don't know what A is, but that's all right. X, well, there's a y-intercept, excuse me, there's an x-intercept at 2. So we can say x minus 2 must be one of the intercepts. Okay, and then the other one, hopefully you can guess, there's an x-intercept at -1, so this one's going to have to be x plus 1. Okay, now what we can say from here is, what is A? All we need to know, if we knew what A was, it'd be good to go. And this is where this information comes in. The 0.36 is on this line somewhere, depending on what A is. So what we can do is, wherever we see a y, we're going to substitute in 6, and wherever we see an x, we're going to substitute in 3, and then we're going to solve for A. So let's do that. So we're going to get 6 equals A, which we don't know, which is what we're trying to find. 3 minus 2 times 3 plus 1. So 6 equals A. 3 minus 2 is 1. 3 plus 1 is 4. So 6 equals 4A, if we simplify that. And divide both sides by 4 and swap the A around. And what we get is A equals 6 on 4, which is 3 on 2. So if we come over here now, what we can say is it's going to be, well, we just need to substitute it into this form here. But now we know what A is. So we can say, all right, Y must equal 3 over 2, x minus 2, x plus 1. And that's our final answer. You can check it on your graph. It will have x-intercepts at +2 and -1. And this A value sort of dilates it or stretches it such that it goes to this point here, 3, 6. All right. Let's keep pushing through. Hopefully we're almost there. Find the points of intersection between the following functions with equations. That and that. Okay, we're going to talk a bit more about this soon, but what we can say for now is when you need to find where any two equations, I should say graphs, intersect, you just need to set them equal to each other. So let's do that. And what we're going to get is, we're going to get 1 mark for just doing that. So that's a good start. We just need to set them equal to each other. All right, now we need to rearrange. So let's do that so that we can solve for x using some of the strategies we've used before. I'm going to subtract 4x from both sides. Subtract 4x from both sides. So I'm going to get minus 6x minus 24 equals 3. And then I'm going to subtract 3 from both sides to get the right-hand side equal to 0. So I'm going to get x squared minus 6x minus 24 minus 3 is minus 27. And that equals 0. Now, again, looking at this, we've got 2 x terms. So that means we're going to have to use some of our factoring skills in order to solve this using the null factor law. So what we're going to get is, all right, what multiplies to give negative 27 and adds to give -6. Well, that's going to be multiplies to give -27. I'm thinking 9 and 3 are looking good. It has to be -9 plus 3. So since this is monic, I'm just going to go straight into putting it in. We're going to get x minus 9, x plus 3 equals 0. And then we can say, all right, x, computer would work, that would be good. X equals 9 and x equals -3. Now, what we need to do is we know that these are the x-intercepts. Sorry, not x-intercepts. These are the points. These are the values, I should say, of x. These are the values of x where these two graphs intersect. But it says find the points of intersection. Now, when it says that, a point in two-dimensional space, say here, needs to be described using two numbers, an x value and a y value. So what you need to do now is take these x values and substitute them into one of the equations. Either one's fine, because at that point they're equal, so you can use either one, and then find out what the y value is. So for example, let's do the second one because it's just shorter and easier. So the second equation says this, 4x plus 3. So your y value is 4 times your x value plus 3, and we know that our x value is 9. So y equals 4 times 9 plus 3. 4 times 9 is 36, plus 3 is 39. So one of our coordinates, which we can write, is 9, 39 for one of the points of intersection. Now let's do the other one. Maybe I'll use a different color. Y, again, use the same equation. Y equals 4 times -3 plus 3. 4 times -3 is -12, plus 3 is going to be -9. Sounds about right. So what we get is, well, the x value is -3 and the y value is -9. And then just to make it super clear for whoever's marking it, you should maybe put a box around your two answers. Okay? I strongly encourage you to go graph these. Something maybe like that. And then the other one might look like this. And what we're saying is, all right, at the point -3, -9, which this might be this one, there's a point of intersection, and at the point up here, there's going to be a point of intersection at 939. So I encourage you to go have a play around on a calculator or on some sort of technology to see that that's true. Now, this last one was tricky, so let's do it as simply as we can. Using the completing the square method, find the turning points of this. Okay, for some reason, I always like to write down the problem just to get a feel for the numbers. So I'm going to do that. So remember, we can't complete the square when it's non-monic. So we need to take that -4 out. So that's a bit annoying, but let's do that. And I'm going to use big brackets because there's going to be a few brackets involved. Take -4 out as a factor. We're going to be left with x squared, all right, minus 3x. Because I'm taking -4 out as a factor, 12x divided by -4 is -3x. So just be super, super careful. A few people made a mistake and forgot to make that negative. All right, and now here it's -5, but I'm taking out -4. Again, -5 divided by -4, which is what it means to take out a factor, is +5 on 4. So that's +5 on 4. All right, that's all right so far. Now what we can do is we leave that -4 there. All right, we can see that this is just a monic quadratic where we need to complete the square. And remember, completing the square, we take the b value. We take the b value, we halve it and we square it. And that's our new c value. Sorry, so I should write our new c value. We take our b value, which is -3. We halve it and we square it. Okay? In fact, I'm going to leave it in this form for now, just because, yeah, it's just easier. But if you did want to work it out, it would just be 9 on 4. If you wanted to simplify it, I mean. But let's just leave it as it is. Let's write that in. So it's going to be 3x. All right, our new C value is this. So let's write that in. All right, let's leave it as a plus because we're adding it in. And it's going to, but it's negative 3 on 2 squared. All right, I'm going to put normal braces around that. And remember, we can't just randomly add in numbers. So we need to also subtract that. We need to subtract that number. And we also can't forget about our old friend 5 on 4. That needs to stay in the mix. So that's plus 5 on 4. And now I can close my square bracket, my red one. Okay. Now, it's getting a bit interesting. What we can say is, all right, this is a completed square. We just need to write it as such. So what multiplies to give negative 3 on 2 squared? And adds to give negative 3. Well, the answer's in the question a little bit. Let's just think for a second. Negative 3 on 2 squared is 9 on 4. So something that multiplies to give 9 on 4, but adds to give negative 3. Well, let's have a look. What if, as I said, the answer's in the question. Negative 3 on 2 times negative 3 on 2. Well, that multiplies to give 9 on 4. Let's see what they add to give. Negative 3 on 2 plus negative 3 on 2. Negative 3 on 2 is just negative 1.5. And if I add negative 1.5 to that, I'm going to get to negative 3. So this whole part here, so this bit here, is just x squared. Ooh. Sorry, yeah, as we factorize it, it's going to be x minus 3 on 2 all squared. Now, what we can say here is we just need to tidy this business up. And this is where it's handy to be confident with using fractions. So let's try it out. So it's minus negative 3 on 2 squared. Well, let's make that 9 on 4 for now. It's going to be minus 9 on 4. Just so we're super clear, this minus is, I should say, this minus sign or this negative sign is this one. These ones are the same. But this becomes positive 9 on 4 because negative 3 on 2 times negative 3 on 2 is positive 9 on 4. But we're taking it away, so it's minus overall. So we've got that so far, which is looking all right. And then we have to add 5 on 4. Okay, hopefully minus 9 on 4 plus 5 on 4. That's handy. They've got common denominators, so we don't have to do anything too crazy. Minus 9 plus 5 is minus 4 over 4. So this becomes minus 4 over 4. Well, that's just minus 1. So this becomes minus 1. And there's your final answer. You might want to do this as well. And I think it's probably a good idea too, is just expand that negative 4 back in. Remember, you do not need to expand it into these brackets. You just need to leave it out the front. So it's minus 4 times x minus 3 on 2 squared. And then you need to multiply negative 4 times negative 1, which is positive 4. And the question, we always make sure we answer the question, find the turning point. Well, the turning point from this can now be read off because we know that it's in turning point form. That was the whole point, right? So we're going to put it in coordinate form. It's going to be, this one's going to be swapped, remember? So this one's positive 3 on 2. And this one's positive 4. This one stays the same. So there's your turning point. And again, make it super clear that that's your answer. Now what it wants us to do is to sketch it. But we've done all the hard work, so that's not too bad. We know the turning point. Yeah, we know the turning point, which is the main thing. So the turning point is at 3 on 2. Well, that's 1.5. So I reckon that's there. And at 4, so I reckon that's there. So there's the turning point. And let's have a look at it. This here is what we're sketching. Obviously, it's the same as this. We just completed the square on that to get what I've just put a box around. Now, we know that the only other thing we might need are our x and y intercepts. So we just need to work those out. I prefer to use, you can use either form, as long as you do the previous part correctly, which we did. You can use, if we use this form, this is going to be really handy to find our y-intercept. To find your y-intercept, you let x equals 0. And that one's easier in this form. -4, 0, substituting in x is 0, plus 12 times 0, -5. -4 times 0, well, that's 0 and that's 0, so that's just -5. So our y-intercept is at -5. All right, the only other thing we might need to find is our x-intercepts. All right, and to find your x-intercepts, it might be easy to use turning point form. If we had it in intercept form, that would be good, but we don't. So we're going to use the turning point form, and to find x-intercepts, let y equals 0. So 0 equals -4 times x minus 3 on 2 squared plus 4. Right, this is good practice in solving these sorts of ones anyway, so let's go through this together. Let's look at the structure of this again. If I take x, the first thing I do to it is I subtract -3 on 2, then I square it, then I multiply by -4, then I add 4. That order is important, okay? Because the first thing we want to undo is the last thing that happened. So we're going to take away -4 from both sides. So we're going to get -4 equals -4 times x minus 3 on 2 squared. All right, the next thing we want to undo is the division, or the multiplication, I should say. So we need to divide both sides. We take this -4, we need to divide both sides by -4. So that's going to be -4 divided by -4 is 1. And these cancel out because that's why we did it. So we're just left with x minus 3 on 2 squared. All right, now we can take the square root of both sides, which is good. So we can take the square root, and remember, it's the plus or minus square root whenever we take the square root of both sides. Plus or minus. So square root of 1 is 1, so that's handy, but it's plus or minus 1. Just so we're super confident with that. The square root means a number times by itself gives us the number under the square root sign. So what we can say is that what number multiplied by itself gives 1? Well, that's just 1. So, and that conveniently got rid of the square root over here. So we're at this stage now. All right, now we just solve for x. And the last thing we need to do is add 3 on 2 to both sides. So we add 3 on 2 to both sides. We're going to get plus or minus 1 plus 3 on 2. Now that's two solutions. The first solution is, and when I say solution again, x-intercepts, is plus 1 plus 3 on 2. So let's do that one. 1 plus 3 on 2, or minus 1 plus 3 on 2. Well, I should say and in this case, actually, because it's two of them. So let's say and that. All right, 1 plus 3 on 2. All right, so that's 1 plus 1.5, which must be 2.5. So that's 5 on 2. And -1 plus 1.5. If I'm at -1 and I add 1.5, it's going to give me 0.5. So that's going to be 1/2. So there are two x-intercepts. So we know that one of them is at 2.5 and one of them is at 1/2. So let's do that. 2.5 must be here. And the other one is 1/2, which must be here. And that's all the information we need. And we can sketch it. And you're going to do a much better job of me than that. Oh, that was almost good. Not too bad. And then you just make your dot bigger. So it looks like you've got the turning point. And you say that the turning point is at 3 on 2, 4. And you also say your x-intercept coordinates, please. Coordinates. So this one's at 5 on 2, 0, and this one's at 1/2, 0. And your y-intercept was at 0, -5. And yeah, that's that question. So it's pretty involved. I did a lot of steps. And yeah, hopefully you can cut some of those out as you get more efficient and get more practice with it. I'll do the calculator one in a little bit and upload that for you guys.